welcome to part 3 of my EG4 solar and battery installation project. Today we're going to be getting up on the roof, installing some roof attachments, some solar racking, doing all the rooftop wiring and junction boxes, grounding, the MC4 connectors, the Buchanan crimps. We're going to be down here pulling some wire for the DC. We're going to be mounting some bus bars that are going to connect our EG charge inverter in the future. We should have a really great series for you to watch today. Let's get into it. All right, so I've got my layout started here. A few things to note. A lot of people use lumber crayons, but they will, really those marks will stay on your roof for 5 or 10 years, and you'll be, if the roof is visible, you'll be looking up at some bright red or yellow crayon marks all over your roof to the end of time. So what I like to do is just to use plain old sideway chalk, and that way it'll just wash off after a few rains, and it's not going to stay up here forever. Another thing, I use 2 different colors. I use one for my attachments or rails and another for the corner of my panels. It's really easy to get turned around up on the roof once you do your layout if everything's in the same color and you end up drilling lines or drilling holes where you shouldn't. So I always like to use 2 different colors. I mark out all the edges of my arrays, the edges of the panels. I mark out the, you want to basically hit your first rafter in from the edge of the panels on every end, and then you're going to want to stagger your attachments. So in my case, where I'm at, I need my attachments at 72 inches on center max, but that means my first, some of my first attachments on the edges will also be at 48, and that way they'll be staggered, hitting different rafters all the way down as I go, and that way it's going to evenly distribute the weight of the racking system and solar panels on your roof. Instead of having all the attachments on one single rafter all the way down your roof, it's kind of distributed amongst different rafters. So today I'm going to be using the Unirac NXT system on my roof. It's just a brand that I trust and I've worked with for years. A lot of people prefer flashed feet, and any real solar attachments are rated to last and not leak over time. The problem is human error. So with flashed feet, you're basically taking a pry bar. First you have to find the rafter, pre-drill, make sure you're hitting the rafter on center. Oftentimes you miss and you've got a bunch of pilot holes that you've got to seal up with flashing. So a lot of times those get missed, and that's probably the #1 source of roof leaks in the solar industry, is pilot holes that have been drilled in the roof that are then not properly flashed and sealed. Next, for flashed feet, you've got to pry up the shingles. A lot of times the flashing is going to hit nails on the next row up, so you've got to pry those nails out and pull them out. And all that really just damages the integrity of the roofing system. You're removing nails that hold the shingles in. You're oftentimes going to break your shingles or rip them. And then at that point, the flashing is really, in my opinion, a little bit useless. If it's great in theory, if there was no human error and everybody was perfect and you would perfectly flash every attachment every time, but in reality that just doesn't happen. So what I've got here is the Unirac Stronghold Butyl attachment. The beauty about this is you do not have to pry shingles, pull nails. It's polybutylene. This has been trusted in the roofing industry for over 50 years. And basically you don't have to pre-drill any holes, so there's never any chance of missing a pilot hole and having that leak into your house. So with the Unirac Stronghold Butyl, you come through, you find your attachments. So again, I've measured these out, but in my, for someone that basically you mark your edge of your panels, you come in and you try to find the rafter, and you can hear the rafter, right? It's going to be real kind of hollow sounding, and then as you get to your rafter, I don't know if you can hear that, but it's a lot more solid. So you can kind of figure out where your rafter is. It kind of has a little more bounce to it, kickback. Once you kind of get used to it, it's pretty easy. But anyways, you find your rafter, you mount the attachment. You use 2 screws to lag it into the rafter. And if you miss, you go to the next 2 holes where you think you're going to hit that rafter. If you miss on the next 2, well, you just sink all 6 screws into the attachment and you leave it deck mounted. And that way, hey, you never have any missed holes to seal up. and you know, it just preserves the integrity of your roof much better than, in my opinion, a flashed foot will. Now, a couple things you may want to note. Technically, you're not supposed to straddle the edge of a shingle. So, you know, in some cases, they do sell little extra butyl pads where you can put additional butyl below. Another thing is you can move it. So you can use any 2 holes on here again. So in this case where I've got this shingle edge, I can line it up right with the edge there and try to hit that. And then again, you know, if I happen to miss and it's not this way, I can just sink all 6 and call it a deck mount. All right, and that was solid as a rock. You could just tell when you're in a rafter, it really locks in. When you miss, it's gonna go in real easy and it might spin. So in this case, I've nailed the rafter dead center. And you really just wanna screw these in till they seat. You know, you want them tight and you want that washer seated against the attachment, but you don't want to lock it down so tight that that neoprene washer blows out and kind of sticks out of the side. That'll cause premature failure of the neoprene washer. So now I've got my first and last feet mounted. I'm gonna go ahead and snap some string lines to make sure they're all lined up nice and even, so that our rails are nice and straight. All right, and I can feel that one sort of curve off the edge of the rafter. So again, I know it's to the right here. All right, so I've got pretty much all the feet down. One thing to mention is I ran out of screws. So Unirac sends 2 screws per foot. I guess they're assuming you're a perfect person, but we all know that doesn't exist out there. So no matter what, no matter how good you are at finding rafters, at some point you're gonna miss a rafter. I'd say probably about 10 to 15% of these feet, I didn't lock that rafter in with the first 2 screws, and I had to add more screws in order to make sure I hit the rafter and it was nice and secure. I think there was only one attachment where I had to use all 6 screws because I missed the rafter altogether. Now, if you're in an area where you've got thick plank decking for your roof sheathing, I've got plywood. That makes it really easy to find rafters. You can hear that hollowness of the roof when you're beating on it with a hammer. But if you're in an area where you've got that thick 1-inch decking, old plank decking, or maybe skip sheathing or something like that, it's gonna make it a lot more difficult or almost impossible to find the rafters on those projects. So in that case, you may even want to order up to 6 screws per foot. Now, I do believe I ordered a couple extra bags of screws because I knew this was gonna be an issue, but it doesn't look like they came with the order. May have been my fault, I'm not really sure. But you know, basically I ran short there towards the end. So that's gonna slow us down for today. I'm gonna go ahead and get the rails mounted on the attachments that do have all screws secured. And I'm gonna have to order some extra screws for the one on the ends and continue this next weekend. So next we set this into the rail. This is what's going to hold the rail itself. I'm just going to kind of leave these lying loose because I'm going to get them all in there, get the rails in, and then we're going to level the rails. So I'm just going to go around now, get all these in there, and then start laying rails. All right, so you just kind of snap them in place. You can feel them kind of click. And then I'm just going to snug it down. These are likely going to get moved. Okay, so I usually like to leave my rails in full length and lay the panels and mark the rail when I'm done with the last panel, marking it exactly where I need to cut it and cut it in. Because when you cut them to length ahead of time and things aren't perfectly square, they don't always line up the way you would like. In this case though, I've just got basically a stack of 2 panels each, and this chimney is kind of in my way over here from leaving these fully extended. So I'm gonna go ahead and go against my own advice here and pre-cut them, and I'm just gonna be very careful to square all these out really well so that when we go to lay panels, everything lines up perfectly. So I am leaving about an extra 3/8 of an inch just to leave myself a little bit of wiggle room. And remember, when you're pulling these measurements, you got to include not only the width of your panels, but also the end clamps and mid clamps. Since I'm using Unirac NXT racking, each clamp, whether it be a mid clamp or an end clamp, is about a 1/2 inch wide. So you're gonna add a 1/2 inch for each end and mid. Now when I cut these rails, I like to turn the blade backwards on the Sawzall, and that's so you can kind of lay it flat and you're on an angle where you're gonna jab gash a hole in your shingles. All right, so today I'm going to install the Easy Solar JB1 XL. It's called the XL for extra large. That being said, it's pretty much just like a standard size rooftop solar junction box. It's made for a shingle roof. Many other manufacturers make products like this, such as a Solidec. Unirac makes a couple different ones. You know, the important thing is that you use a junction box rated for the application. In this case, we're penetrating a shingle roof. We want it to be designed that way and installed per the manufacturer's recommendations. So I'm going to choose an area. I'm going to have it under the solar panels so that it's hidden from view from the road, because my array is visible. Some people might put it outside of the array if it's not visible and they want it to be easily accessible. I'm putting it under the last solar panel in the row, so that way it's very easy to get to. If I ever need to get back into the junction box, I just need to lift the end panel and I can get right to it, and it's not in the middle of the array somewhere. Next, we want to make sure we're not going to hit a rafter. In this case, I know my rafter's right here. We got hollow roof, so I'm going to kind of pick my location here. I'm going to use the lid as a template. And I'm going to make sure that it is between 0 and 2 inches down from the next course of shingles. So in this case, let's just go with 1 inch. All right, so that's the outline of the box. In this case, we're going to be flashing the box up under this layer of shingles, and then we need to make sure that no nails are going to prevent it from coming up under the next course. So when you do this, you want to take it nice and easy. Make sure you don't rip any shingles. All right, I think I'm going to be clear nails, but we'll find out when we go to flash it up under there. So next I'm going to cut my shingles. I use a pair of old tin snips. I know it's probably not great for the blade, but they do make a great shingle cutter. Now we're just going to test flash it. Oh, it fits like a glove. We didn't hit any nails, which is great. That means we don't have to pull any nails out. So in my case, I'm going to be using Buchanan crimp splices. This is what's called a DIN rail. It's made for these snap-on little connectors from where we transition from our PV wire to our THHN. In my case, I'm not going to use the DIN rail or those terminal blocks. I'm going to use Buchanan splice connectors. So I'm going to just go ahead and pull this out of here and get it out of the way. One thing I do like about this box is it has 2 little weep holes in the bottom, so that if water ever does get in somehow, it's going to drain out of the bottom of the junction box. A lot of times you have to drill those holes yourselves when you're working with other manufacturers' junction boxes. All right, so next is the drill zone. I'm going to be bringing 1-inch conduit into this to bring my PV strings and my communications cable for the Tigos. And we kind of want that in this area, you know, above the layer of shingles. The box will come with some instructions on the drill zone. In my case, I'm just going to put it right up here near the top. So I'm going to use a hole saw, and I'm sizing this hole to be the diameter of my conduit fitting. So now I've got my hole drilled for my conduit fitting. Now something a lot of people are going to kind of screw up here is that we want a larger hole for the hole that's going through our roof deck. The reason being is this conduit fitting is going to be sticking down through the deck, and it's wider. So if you only drill the hole this size, you're not going to be able to get your conduit fitting up into the back of the solar deck. Or in this case, the Easy Solar Junction Box XL. So we'll test fit that. We're going to get that fitting in place. If you're working with multiple people, you know, you might have someone in the attic stubbing the conduit up while you put on the lock ring, but I'm working solo here, so I'm going to try to do that, you know, ahead of time, so it makes it easier to install the conduit in the attic by myself. All right, so now we're going to do the larger hole. Real generous with the sealant right here by the penetration, but I'm going to leave the bottom open so that if for any reason water ever does get under there, it's going to be able to easily drain. Now we're just going to drive our screws through. And we're just going to put another layer of sealant across the upper edge. It's really not necessary, but belt and suspenders, as one of my great mentors used to say. All right, so this thing is installed and ready to rock. We're gonna save wiring it up for another day. So I'm just gonna go ahead and put the cover on. You'll notice these stainless steel screws are the ones for securing the box. Here I'm just making sure that any of those nails I had to pull out are going to be nice and sealed up. So that we don't have any water ever making its way back down in here. All right, so now that we've got our racking up, I'm going to go ahead and start squaring the rails again because I did not leave myself plenty of room here. We're going to square up the rails, take our time here and make sure that we've got a nice neat square and all the panels are going to lay down perfect. After that, we're going to run a string line atop the rails because we want a nice flat plane. This is a very wavy roof, so it is going to be a struggle to get all the rails into a nice flat level plane, but we're going to do our best with what we have to work with here. Okay, so we're going to start out by just pulling this rail 10 inches off the bottom and locking it in. I'm pretty sure we're already there. Yeah, looks like we're at exactly 10 inches here. I'm going to go ahead and put the foot about halfway up. Lock it. We're going to get our other rails out of the way so that we're just kind of working with our top and bottom rail for the moment. All right, so we're going to go ahead and pull this one 10 inches. Looks like we're pretty much already there. I'm going to pull it about halfway up the foot. We're just going to look at the overall length of this top rail. It's cut short already. That's 84.5 inches. All right, so we know our top rail is 84.5 inches long. We're going to come to our bottom rail. We're going to measure out 84.5 inches. We're going to mark it. All right, so now most people might have a second person. This is what is ideal in this scenario, and you'll pick one corner of the tape measure to put to that corner of the rail. I'm just going to have to try to center it because obviously I can't really play a balancing act with the tape measure here. So I'm just going to try my best to center that corner on the center of that tape measure. I'm going to pull it up to the edge of this rail and get my measurement. So to the top of the tape measure, I have 193 and 5/8. So next I'm going to do the same thing with this one. I'm going to try to center that tape measure as best as I can. We're going to pull it to our mark, to the top of our tape measure. We got 194 and 3/4. So we're off by like 1 1/8 inches. This way it's longer, so we want to make it shorter. The way we're going to do that, we're going to keep this bottom rail as our point of reference. We're going to move the top rail over to the right. Roughly, we'll just give it 3/4 inch and see what happens. So I can just mark my rail at the foot here. .194 and 5/16. All right, 194 and 5/16. All right, so now that we got our top and bottom rail locked in, we're going to pull a string line from the top to the bottom, and we're going to line all of our other rails up in between. So we'll tie a little knot. We'll just hang it on the bolt down here.
Now we're gonna pull our rails to the edge. We're just gonna go, right, we don't want it actually to touch the string. We just want it to barely just kiss the edge of that string. And we'll just set these about halfway up for now. We're gonna do both bolts. All right, so I'm sure you got the point by now. We're gonna go ahead and do this across the entire array and continue on. All right, so now we've got our Unirack splice kits, rail splices. They're pretty simple. You just slide them into the rail. There's a little line right here that you want to line up with the seam. Me personally, I like to leave a tiny little gap, and that way it just provides a little bit of room for thermal expansion and contraction. I'm just going to use like a little, maybe 1/16 to an 1/8 inch of a gap there, and we're going to lock these into place. All right, and so that bonds the rail together electrically, as well as kind of connecting it together securely physically. So I can't stress enough how important grounding and bonding all of your racking and all of your components on the roof is. For those of you out there that might be DIYers and think it's a step that can be sort of overlooked or ignored, it can't. It's very important. It's due to safety. If at any point you pinch a wire on the roof or anything metal on the roof gets electrically energized, which is extremely common in solar. Somebody pinches a wire under a module, squirrels come up here and chew the wires, something like that, and a hot wire touches metal, it needs a way to clear that ground fault, to follow that ground wire, you know, back to the source and trip a breaker or an overcurrent protection device so that it de-energizes the system until you can hunt down that ground fault and fix it. If you don't, what happens is you've just got a solar panel or the racking up here energized with high voltage DC current, just sitting here energized, and it doesn't clear a fault. The system just keeps running. Everything seems like it's fine until someone comes up on the roof and touches something the wrong way. They become that path to ground and get electrocuted, fall off the roof. You know, I just can't stress enough. High voltage direct current is nothing to play around with. You have to ground and bond everything electrically. It's critical for the safety of your system. So I've got these two fittings here. I just picked these up at Home Depot. They make some better ones that are like 1 inch or even bigger, which I wish I had on this project, but I didn't order them ahead of time. I'll look around online and try to leave some links down in the description below. But we're going to go ahead and use these 2 3/4 inch ones. That should take care of our 3 strings plus our equipment grounds. All right, so next they make these Unirack MLPE/grounding lugs. They're used for both securing down module level performance enhancers, as well as locking down your equipment ground to ground and bond all of your racking on the roof. This bites in to the aluminum and it creates an electrical bond between this, the ground wire, and the aluminum racking, just to make sure that it's all bonded and there's a nice solid path to ground in the event of a ground fault. Another thing to mention is that it's industry standard to use number 6 bare copper to bond all the equipment on the roof. That is required by code. Most inspectors consider it to be exposed to physical damage, and number 6 bare is the smallest conductor you can have when you have a ground wire exposed to physical damage. All right, and then another good thing to do once you have your ground wire there is you just kind of do a couple little turns like that. It kind of tightens that ground wire up. So that way when you use it to attach all of your wires to, you got a nice solid wire. It's not all saggy under the array to where it's going to let your wires sag and hit the roof. All right, and so technically you don't need to use one bonding lug per rail. You really only need one bonding lug for every other rail or every row of solar panels. So for every continuous row of solar panels, you need one bonding lug for that row. And that's because the mid and end clamps also bond the solar panel frames to all the racking, and so everything's kind of bonded together. Me, I just like to hit every rail regardless, just again to make sure no matter what, I've got a nice clean path to ground no matter what happens. Again, as a great mentor of mine once said, belt and suspenders. Okay, so now we're going to run our PV wire. This is number 10 PV wire. It's rated to be in the sunlight, 90 degrees C. This stuff here is up to 1,000 volts. By code, I think you only are going to need up to 600 volts, but I went with the 1,000. Most of the time I like to use red PV wire for my positives and black for my negatives. By code, you don't have to. PV wire is one of the wires that has that exception that allows you to use marking tape, even though it is smaller than 6 gauge. In this case, I just bought one big roll of black, just because you save money when you just buy one large roll. So what I'm going to do is I'm going to use red tape to identify my hots and white tape to identify my negatives. And then I'm going to use 1 wrap for string 1, 2 wraps for string 2, 3 wraps for string 3. Now, if you're not using optimizers like I am, you might want to think about what panels are going to be in the shade at what times, and try to string up your panels to where ones that'll be shaded at the same time are on the same string. I'm using Tygo optimizers in this system, so it's not as big of a concern, but I'm still going to string it up as if I don't have those optimizers installed. All right, so a few things you should know about the PV power source circuit. So the PV power source circuit is the DC circuit between the solar panels and the inverter. So for microinverters or things like that, you don't have to worry about it. That's just a little jumper on the roof. But for DC connected solar panels that are running through your home, you've got your photovoltaic power source circuit. Few things to know about that. It's got to be enclosed in metal conduit. So that can be EMT like this. That can be flexible metal conduit. It can be metal lined liquid tight conduit. It can even be like armored cable or MC cable. There's many options you can choose, but it has to be in metal conduit. In my case, I used EMT because I had a little bit left and I just figured I'd finish the last little run with EMT while I was at it. But honestly, that's kind of nonsense. Nobody that's on the clock would do that just because it, trying to climb up and back forth out of an attic, bending conduit is just not really feasible. So most people would use flexible metal conduit in the attic space because you can just terminate it, run it through the attic, strap it. You do have to strap it much more often. Flexible conduit and MC cable, things like that, usually have to be strapped every 3 feet. EMT only has to be strapped every 10 feet or 3 feet from a termination. But in this case, I just hard piped it with some EMT. Regardless, I've got it strapped here. Another thing about the PV power source circuit is it has to be at least 10 inches below the roof decking. And that is because if a firefighter comes to a house fire and they're cutting vent holes through your roof decking from outside, they need to be protected and know that they're not going to run a blade through that DC, that high voltage DC PV power source circuit. So that just leaves them enough clearance to do what they have to do and know that they're not going to cut through high voltage DC conductors. Another thing to know is you have to have these warning photovoltaic power source stickers within any wall or partition. So any time that it transitions to a different section of the home, there has to be one, and they have to be every 10 feet. And they have to be bright red and reflective. And the reason for that is because, they don't want an electrician coming back behind you and just trying to cut in a light switch or an outlet and just see a circuit and say, oh, I'll tap into that one. Right? We want to notify that electrician with this bright red shiny sticker saying, watch out, this is not a normal circuit, this is a PV power source circuit. So now we're going to install our paralleling cables. It's essentially just a positive and a negative with the 2 Detson connectors on the end and a little Ethernet cable or RS-45 cable. Alright, so I've pre-marked my comms terminal there with a Sharpie just so I didn't get confused. But essentially, this is going to be the last battery of the 2. So it's basically just going to connect to the other battery, which is then going to connect to the inverter. Alright, so at this end, we're going to plug it into the battery terminal. So I'm going to go ahead and pull the wire through first. I'm going to go ahead and plug this into the battery terminal. There we go. Now over in the other battery, which is going to head to the inverter, I'm going to plug it into the COM terminal. Alright, and we really just need one negative and one positive to run from this battery to the other. I'll go ahead and pick these 2. So this is my positive cable. I'm gonna go ahead and connect it right here. Alright, I heard that nice audible click. Do the same over here. There we go. Nice audible click. Same thing on this side. right, well that was easy. So for now, I'm just snugging these wires down real good, but I'm gonna come back later with the torque wrench and torque them to spec. All right, so next I've got these Polaris lugs. These are go from 350 to 6 gauge stranded, aluminum or copper. So EG4 is going to say no aluminum in the GridBoss. I personally think that's a little strange and maybe nonsensical. I've never seen any terminal really that's only rated for copper. I mean, it's really no different. Aluminum just needs to be upsized and you need to use some no lux on it. But aside from that, there's really no reason I can imagine that these terminals could not take aluminum. But anyways, I'm going to just do it by the books regardless. And your feeder cable technically has to be kind of protected from physical damage. So having it kind of run down here on the wall is a little sketchy anyway. So I'm going to, when I cut power, I'm going to bring my existing feeder into this J-box. This is where we're going to transition from copper to aluminum. And again, the smallest wire I've got here is a 6 gauge copper ground. And that is the smallest wire that'll fit in this Polaris lug here. And if you're stripping big cable like this a lot, these Klein wire strippers here for large gauge cables, they are just a necessity. I worked in the industry for probably 6 or 7 years before I finally got myself one of these. And man, it just saves so much time and effort. These things are awesome. I'll drop a link down in the description below. Alright, so what I'm doing here now is I pre-ran my fish tape through my conduit to get a length of my wire. Now if you're an electrician, obviously you've got tons of wire spools in your van and you're running around. Well, it's pretty easy. You don't need to pre-measure your wire. You just run your fish tape up through there. In this case, I've got 3 strings plus a communication wire for my Tigos. So what I would do is I would run 3 rolls of number 10 red THHN, 3 rolls of number 10 black THHN, and a roll of the 18 gauge twisted shielded. And just pull them, you know, terminate them, go cut them to length at the other end, be done with it. But in this case, and in most cases, if you're someone at home, DIYer, you're not going to have a bunch of different spare rolls of wire. You're probably just going to buy one big roll of wire for your project. So what that means is I'm going to have to pre-measure first by running my fish tape through the conduit, marking it to length. I'm going to pull my fish tape back out of the conduit. I'm going to lay it out in the driveway, and I'm going to run 3 rows of red, cut them to length, 3 rows of black, cut them to length.
It is going to be difficult not having them get all tangled up in a big rat's nest, which is another reason why it's great to just unspool them right off the wire roll and cut them to length. But in this case, I just can't do that. So we've got it pulled, we've got it marked. I'm going to go ahead and pull my fish tape back out, get out there and start cutting some wire. Alright, so now for connecting our wire to our fish tape. Now a lot of people, if it's a long pull with a tight conduit, you're going to want to braid all these together. You're going to strip them all and braid all the copper together. In this case, I've got an easy pull and my conduit's a little bit oversized, so I'm good. I'm not going to go and do all that. It's kind of excessive for what we're doing here. So instead, I'm just going to strip this wire. Going to run it through the end of this fish tape. Yeah, you could even like twist a little bit. And then you'll see the ends of my other wires are kind of stepped down. You don't want to have any big sharp edges that are going to get caught up in your conduit somewhere. So you kind of want to gradually step all these wires into the pole. So I'm going to be installing some of these Victron 600 amp 8-pole bus bars for my battery cables. It's a little bit overkill, but this is all I could find in stock. So I've got 2 of these bus bars, which I'm going to be connecting my battery cables to, and in the future I'm going to be connecting an EG4 charge inverter to, so I can use my cheap little standby generator to charge up the battery bank. So human-made electrical connections in a solar PV system are the #1 source of failures. This is going to be where the vast majority of your problems arise. It's super important to have very good connections. In this case, I don't like to use wire nuts. A lot of people in the industry still do that, but that's really just not a sufficient connection for high voltage DC conductors. What I like to use is the Buchanan splice crimp tool. So that's going to consist of the splice caps. In this case, I've got ones rated for 2 number 10 wires. It's got the insulator cap, and I've got the tool here that crimps that splice cap down. So I'm going to go ahead and use my Klein solar wire strippers. They work on normal wire such as THHN as well. I really like these things. I'll go ahead and leave a link down in the description. But essentially, you know, you come in here
and strip the wire. You feed both wire ends in and you leave the flared end facing the wires. So you want the tapered end at the tip of the connection. Okay. And you're going to take your tool, crimp it down. Go all the way. And there we go. We got a nice tight connection that is not going to come loose no matter what. We go ahead and throw our splice cap on, and that flared end sort of locks in to those bites. And that is a nice solid connection that's just never going to come loose, and you're never going to have to get back in this junction box again. All right, so our rooftop combiner is all wired up. We've got our equipment ground on the rack connecting to our equipment ground going down to the inverter. We don't need a vinyl bushing here because these wires are smaller than 6 gauge. We also do not need to worry about having a grounding bushing up here because that conduit is grounded down at the inverter. All right, so now we've got our connections to the solar panels. These are going to be using Staubli MC4 connections. So depending on the brand of your solar panels, they may use the Staubli MC4s or they may use the Amphenol H4s. Now I've used those together, mated together for 10 years in the solar industry. I'd never had any issues, but technically I don't think they're a UL listed connection. So in this case, my solar panels are utilizing MC4 connectors, so I'm going to go ahead and utilize Staubli MC4 connectors. Now, Staubli is the original manufacturer of the MC4 connector, and you do not want to cheap out and just buy some generic MC4s off of Amazon. You know, there's no testing, there's no tolerance with those, and you can end up with a bad connection and arcing and failure of the connections. Again, connections are the #1 source of issues in the solar industry. You want a nice solid connection. Go ahead and spend a little bit of extra money. Get the ones made by Staubli, and you know that you're going to have a nice UL listed connection that has been tested and is tried and true. This can get pretty confusing up here. Reverse polarity is very common because, hey, I've been in the industry 15 years, but hey, it's been like 7 or 8 years since I was really out installing this stuff in the field. And even I got a little turned around on this project. So what you need to know is you've got your your plastic connectors and your metal pins, right? You've got what looks like a male plastic connector and a female plastic connector. You see? And then you've got a male metal pin and a female metal pin. Now your female metal pin goes in your male plastic connector, and your male metal pin goes in your female plastic connector. Lastly, the official way to refer to these connectors is by the metal pin. So what's going to look like a male connector when you're done is actually considered the female connector, because the final name of the connector is based on the metal pin, not the plastic piece. So in this case, I'm going to crimp the female connector for my negative home run, because the male connector coming off of the solar panel, which has a male metal pin, is the negative lead from the solar panel. We want negative going on our negative home run. It's very important to take your time, really think about what you're doing, because it's very easy to get mixed up on the roof and crimp the wrong connectors on the wrong home runs. So, not only do you want the Stably brand MC4 connectors, you also want a decent brand MC4 crimping tool. In this case, I've got Klein, because I just have used their tools forever. They're trusted in the industry, and they're a good manufacturer. I also have my little Klein PV wire strippers up here as well. I'm going to drop a link to all this stuff down in the description below, just so you can make sure you know where to get good quality tools and the Stably connectors. So in this case, I'm going to take my Klein solar wire strippers. I'm going to use the 10 stranded setting. I'm going to go ahead and knock a piece off there. I do just enough wire for it to kind of go up into that metal connector, just the hair. Next, I've got my Klein MC4 crimping tool. I'm going to go ahead and drop it in the number 10 die. And I'm going to actually, what I'm going to do is I'm going to sort of pinch these together a little bit first so that they fit in the die. I'm going to drop it in my number 10 die. All right, you see that? We're in the die. I'm going to put my wire in, and I'm going to crimp it down. And I'm going to crimp till this thing is all the way shut. And you'll see that is a nice solid connection, nice UL listed connection. It is not coming loose. That is tried and true. Again, this is a female connector, even though it looks like a male connector. So you push it in until you hear that audible click. Now they make some little MC4 tools. Technically, for this to be a UL listed connection, they have a not only these little plastic torquing tools, but you've got an actual metal torquing tool to torque these to spec. Honestly, I've never used them, but if you want it to be a true UL listed connection, that's what you would use. In this case, I don't have my little plastic tool up here at the moment, so I just use the old tried and true method of using my teeth. I do that, I tighten as much as I can by hand, and I call it a day.
It's what the crimp is supposed to look like. That sucker's not going anywhere. Alright, so I think that's going to conclude the weekend for me. That's about as much as I'm going to get for part 3 of the install series. I'll go ahead and try to get this edited and posted as quickly as possible. And then again, I'm trying to make as much progress as possible as I can with the time that I've got. Really appreciate each and every one of you. If you're looking for any of the tools or parts or equipment that I've used in any of these videos, check out the links down in the description below. You may be able to save yourself a little bit of money. Like, subscribe, press that notification bell, or leave a comment down in the description below. I really appreciate each and every one of you. Until next time, take care.